Alrighty. Okay, so trig ratios. There are 6 of them. Okay. The 3 most common are the ones you talked about last year in Math 2. Sine, cosine, and tangent. Some teachers teach the SOHCAHTOA to help you remember that sine equals opposite divided by hypotenuse, cosine equals adjacent divided by hypotenuse, and tangent equals opposite divided by adjacent. So those are the 3 common ones. The 3 that you might not have seen last year are similar, are reciprocals, I should say. Reciprocals means flipped, right? Cosecant. Cosecant is sine flipped, right? Opposite over hypotenuse is sine. Cosecant is just the flipped version of that, the reciprocal. Cosine is adjacent over hypotenuse. Secant is just the flipped version. Same thing, tangent and cotangent. Okay? So they're in your notes. You don't have to memorize them. It's not something to memorize. It's just we're gonna work on how to use them. We only use these for right triangles. For right triangles. So that's the only type of triangle we're going to talk about today. Just right triangles. Okay? So right triangles can look like that. They can look like that. Pretty much any way. They have 3 sides, and one of the angles is 90 degrees, right? That's a right triangle. Okay, so they have 2 parts, 3 parts. The sides. The sides are called legs. Those make up the 90 degrees. Okay, so the 2 sides that make up the 90 degrees are called the legs. The side that's opposite of the 90 degrees, the long side, is called the hypotenuse. Hypotenuse. Okay. All right, so we talked about hypotenuse, right? Hypotenuse is the one that's in the purple color. Opposite. What does opposite mean? If where I'm standing, if like location-wise, what do I mean by when I say something's opposite that? What do I mean by when I say something is opposite where I'm located? Flipped, or what's another way? Something you're facing, right? I'm facing you guys, so you're opposite of me, right? Usually something you're facing, right? What does adjacent mean? Adjacent's the other one. What does adjacent mean? If I'm here, like what if you're talking about your location, what is adjacent? To the side. Yeah, either side. Either side. Right? Usually not in front, usually we call that opposite, but to the sides, right? Like in this classroom, we're adjacent to Mr. Yates right next door. We're adjacent to Mr. Aguila right next door. Okay? That's adjacent. So when we're talking about that, we're talking about location. Okay? That's what adjacent means. So let's go down. Let's do a little bit of review from last year. I took this from a Math 2 book just to kind of get the brain going, remember this stuff. Okay? So this right triangle has 3 angles, A, B, and C, right? A, B, and C. C is the right angle. It's also got 3 sides, X, Y, and Z. Okay? So angles are A, B, and C. Sides are X, Y, and Z. Okay. So it says give the ratios. Ratios is a fancy word for fraction. Give the fraction for the following trig functions. Okay, so let's do the first one, sine. Sine of A. So the first thing you always do is find angle A. Because it'll always, anytime you have sine, cosine, tangent, cotangent, cosecant, it'll always be followed by an angle. Okay? So this part here, sometimes it's parentheses, sometimes they don't put it in parentheses. It's angle. Okay? So first thing we got to do is find that angle. Okay? That angle is right here. Right? That opening is right there. Okay. So I'm looking for, so it says sine, right? sine is opposite over hypotenuse. So what side is opposite of A? What side? Y, right? Y is facing side. Y, so if I'm here, if I'm at this angle, Y is facing right straight across, right? So we're going to put Y on top. And then the hypotenuse is Z. Right? These are the two legs. The other one's the hypotenuse, Z. Okay? All right, so let's go to cosine now. Cosine. Now I'm still at A. I am still at A. So now I don't want, for cosine, I don't want opposite. I want adjacent. So which side is adjacent to A? Yeah, there's actually two, right? X and Z. Aren't X and Z close, to, like right next to A? Right next to it, right? But Z's already got a different name. Z is known as a hypotenuse. So we don't count Z as the hypotenuse. So yeah, so X would be the only one. So X over hypotenuse Z. Okay, so now we're moving spots. For letter C, we're moving spots. I'm not at A anymore. I'm at B. Tangent of B. Well, tangent is opposite. So opposite of B, opposite side for this would be X. Adjacent to B is Y. Okay, so what I want you to do now is do the rest of them. Create the fraction for the rest of them. Okay, so these are the fractions for each of them. So a couple things. Cosecant. So cosecant for G. Cosecant of A is just the reciprocal of sine of A, right? Because cosecant, those two are just reciprocals of each other. Okay. Same thing with secant. Secant of A is the reciprocal of cosine of A. Cotangent of B is the reciprocal of tangent of B. Which ones share the same fraction? Which guys share the same fraction? Are there any that have the same answer? A and G, right? This guy and this, let's see, A, which one? A and G? Close, they're reciprocals of each other. They're reciprocals, so they're flipped. But anyone have the exact same? Yeah.
So for F, it would be tangent of A, and tangent is opposite over adjacent.
Oh, yeah, it should be flipped, right? Yeah, sorry. Should be Y over X. Yep, thank you. Because it's A. And which other one?
Well, I don't understand how which one's adjacent.
Oh, okay, so we'll go over that, yeah. So like, if I'm at B, right? Which sides, so let's see, B, right? Which sides, X, Y, or Z, are closest to B? Like touching this angle here. You have two of them, right?
X and Y.
Not X.
Oh, no, Z and Y.
There you go, Z and Y, right? Yeah. But one of them's already got a different name. Which one has a different name that we use? Doesn't Z?
Hypotenuse.
Z already has hypotenuse, so we don't consider that, yeah.
Is hypotenuse the longest one?
Yeah. Yeah. So whatever it's touching, like A is over here, X and Z are touching A. But we don't count Z because that one's got a different name. So yeah, which leg? I should have said which leg is closest. That's a better question, yeah. Yeah, so when you're talking about adjacent, it's always which leg is closest to the angle. That's a better way to ask the question. Okay, so which ones have the same? Let's see. Let's see, B and D. Yup, B and D have the same, right? B and D have the same. So if I find cosine of angle A, and sine of angle B, they're going to have the same fraction. That's true. A and E, right? A and E. And F and I. So it was H, but there was two H's, so the last one. All right? So they all depends on where the angle is. It all depends on where your angle is. Okay? We're going to do the same thing on the other side. The only difference is they're going to give us numbers now. Instead of X, Y, and Z, they're going to give us numbers. That's the only difference on the other side. Okay? So let's look at the other side.
Is the hypotenuse always one opposite from the right angle?
Yeah, always. That's how you can always tell. That's the way to tell if it's always going to be opposite of the right angle. Okay. So a right triangle has three sides. We talked about it. Two of them are called legs. One of them is called the hypotenuse. The two legs are always the ones that make up the right angle. And then the other one is called the hypotenuse. Okay. So back in junior high, maybe even earlier, you guys talked about a thing called the Pythagorean theorem. Pythagorean theorem. Pythagorean theorem helps us when we have a right triangle and we're trying to find side lengths. If I know two of the sides, if I know a leg and a hypotenuse, or if I know two legs, I can find the other side using the Pythagorean theorem. Sometimes you'll see it called a squared plus b squared equals c squared. It's the same thing. I prefer to use the words because it's always like, because every time you see a squared plus b squared equals c squared, right? You're like, which side's A? Which one's B? Which one's C? It gets confusing because C is always going to be the hypotenuse. Leg can be A or B. Leg can be A or B. So it gets confusing, so I just use the words. Okay? Okay, so now number two. We got to find the missing side. So the first thing we need to do is to determine if it's a leg or if it's a hypotenuse I'm missing. Well, let's see. The easiest way to tell is I always highlight the two sides that make up the 90 degrees. These two sides make up 90 degrees. So those are the two legs. So the one I'm missing is over here. So I'm missing a leg. Okay, I'm missing a leg. So I'm going to go over here and I'm going to say one of my legs is 5, right? So 5 squared plus the missing leg squared equals 9 squared because that's the hypotenuse. So this is the missing guy here. I have to figure out what that is. Okay. So what I can do is square them. So 5 squared is 25. I don't know what the leg is, so I'm just going to write the word leg. 9 times 9 is 81. So I have to solve for leg. So what's the first thing I'm going to do here? We've done this lots of times. Yep, that's the first step. Subtract 25 from both sides. So we get leg squared equals 56. Okay, almost there. I almost got leg by itself. I still have that squared though. What's the opposite of squared? How do I get rid of a squared? Square root it. So square root both sides. So now leg is by itself. And I have the square root of 56. So let me go to my calculator. The square root of 56 is irrational. What do I mean by irrational? I can't change it to a fraction. If I could change it to a fraction, there'd be a little fraction button over here, and I can't. Okay, it's a long decimal that never ends. And it didn't say anything about rounding, right? It didn't say anything about rounding. So what I'm going to do is I'm going to have to reduce it. Simplest radical form. It's a square root, right? Look for pairs. Are there any pairs in 56? Does 56 have any pairs? That's what they mean. So let's see. 56 is 8 times 7. Circle the 7 because 7 can't be broken down anymore. 8 is 4 times 2. Circle a 2. 4 is 2 times 2. So how many pairs is 56 going to have? 1 pair, right? So I can take out a 2. Right? I can take out a 2 because I had a pair of 2s. What's left over? 14, yeah, 7 times 2. 7 times 2, which is 14. That's what the missing leg is. The missing leg is 2 times the square root of 14. And that's as far as we can go because 14 doesn't have any pairs anymore. It's just 7 times 2. Okay. All right, so let's look at letter B now. Letter B, find the missing side again. Well, is it a leg or is it a hypotenuse? Well, my 2 legs are here and here. My hypotenuse is right here. So I'm missing a hypotenuse. Okay. So let me use my equation to find that missing side. So I'm going to say 7 to the second power plus 4 times root 2 to the second power equals hypotenuse. I'm not going to write the whole word. I'll just write HYP. Okay, this is what I get to get by itself. So 7 squared is 49. So there's 2 things being multiplied together, right? Inside the parentheses, a 4 and a square root of 2. Well, 4 squared, so they each get a squared. So 4 squared is 16. All right. Let me write it over here. What about the square root of 2 squared? So this is what I have. I have 4 times the square root of 2 squared, right? So I'm going to give this guy a squared, and I'm going to give this guy a squared. So this guy is 16. This guy right here is times itself. Well, what is the square root of 2 times the square root of 2? Since they both have roots, I can multiply them together. And what is the square root of 4? 2. So really, this answer is just positive 2. Okay, so let me go back to my question. So it's 16 times 2. 16 times 2 is 32. (49) and 32 are both on the same side of the blue line, so I don't have to do the opposite. I can just add them. So when you do that, 81. Square root. Luckily, 81 has a nice whole number for a square root. So we don't have to do any pairs or anything. Okay. Okay, so now we're going to do the same thing we did on the front. The only difference is they're giving us numbers. Okay, so 4. Cosine of A. We have to use this triangle to figure out what cosine of A is. Okay, so from the front, I know that cosine is adjacent over hypotenuse. So let me go find where A is. A is right here. Okay. So adjacent to A. Which side is adjacent to A? Which side is touching A? Which leg, I should say. Which leg is touching A? 3. So 3 is going to go on top, and the hypotenuse goes on the bottom. Here's the thing. Here's one of the things you didn't talk about in math 2, because you never had this come up. If I have a fraction, I can't have a fraction end with a root in the bottom. I can't have a root in the bottom of a fraction. Root on top is okay. Like if this guy was on top and 3 was on the bottom, that'd be okay. But I can't have a root on the bottom. So how do I take care of that? It's called rationalizing. This is what you're going to do. Rationalizing involves multiplication. I'm going to multiply by that thing that's causing issues, which is the root. You multiply, whatever I do to the bottom, I got to do to the top because it's a fraction. Okay, so let's start with the top. I'm going to multiply these two guys together. Does that make, can I multiply and make 39? No, yeah, because one has a root and one doesn't. So what do? I just write them. It's still multiplication, but I don't actually make 39. I just have 3 and then times the square root of 13. Now I have the square root of 13 times the square root of 13. Let's see. So I have the square root of 13 times the square root of 13. Can I multiply those two square roots? When I do that, I get the square root of 169. Take a wild guess. What do you think the square root of 169 is? 13. So that's the quick way to do it, right? You can go from here straight to there. Anytime you're multiplying, it's the same, you're squaring it. It's just going to be that answer. So the 13s, I can't do that because one is the square root and one is not. So that one's not an option. But what I can do is try to simplify the guys on the outside. Can I simplify 3 and 13? Can I reduce that fraction? Nope. You are done. If you can, do it. If you can't, don't. Guys on the inside, you can simplify. Guys on the outside, you can simplify. But you can't simplify someone on the outside and someone on the inside. Okay. All right, number 5. Sine of A. So we're still at A. Different triangle, but we're still at A. Okay. A says opposite. So the side that's not, the leg that's not touching A. The leg that's not touching A is A. Over hypotenuse. No roots. I didn't even have to use root 80. It's better that way. Sometimes you do, sometimes you don't. Reduce the fraction. Divide it by 4 to make 2. Divide this by 4 to make 3. You're done. Okay. Okay, so the last side. The last 4 problems are exactly the same as what we've been doing. The only difference is they don't give you a picture. So we have to draw the picture first. They don't give you a visual. It's a lot easier to do if you have a visual. Okay, so let's look at number 6. More words because there's not a picture. A picture is worth 1,000 words. That's why they write so many words, because there's no picture. If they had a picture, they wouldn't need that many words. Okay, so there's a triangle. There's a right triangle that we're going to draw in a second. If I were to find tangent of its angle A, that answer would be 5/6. Okay. This part, don't worry about. The quadrant 1 part, don't worry about. Don't worry about that. Find the exact value of cosine of A in the same triangle. So it's the exact same question as 4 and 5. The only difference is I don't have a triangle. So let me draw a triangle. That's the first step. They don't give you a picture, draw a picture. So you're going to draw a right triangle. So the right triangle can look like any right triangle you want. Whoops. There we go. Yep. Drew it on the wrong problem. There we go. Okay. Label A, B, and C. You can put A here. So, let me put A. Doesn't matter where A and B go. C always has to be. C is going to be the 90 degrees. So A and B are interchangeable. So they said tangent of A. Right there. Tangent of A is 5/6. Well, how do we do tangent? How do we find tangent? What do we do? What divided by what? Opposite over adjacent, right? So opposite is on top. 5's on top. So 5's going to go opposite. 5's going to go there. Adjacent is this side over here. I don't know what the hypotenuse is. I don't know what that is. So let's answer the question. Next, the question says, give me cosine of A. Cosine is adjacent over hypotenuse. So what is adjacent to A? Which leg is adjacent to A? 6. Do I know the hypotenuse? No, I don't know the hypotenuse, right? Can I figure out what the hypotenuse is, though? Yeah, using the Pythagorean theorem. So that's what we're going to have to do first. I'm going to have to figure out the missing hypotenuse first. Okay. So I know this guy is 5 squared plus 6 squared, because those are both legs. Okay. 25 plus 36 equals hypotenuse squared. 25 plus 25 plus 36 is going to be 61. Take the square root of hypotenuse. Does 61 have any pairs? I don't think so either. I think the only way to make 61 is 61 times 1. Makes it nice for us since we don't have to reduce it. So that means the missing side is going to be square root of 61. Now I can finish the problem. Am I done with the problem? No. I have the fraction. That part's done. But now I have to rationalize it. I have to fix it so that square root's not on the bottom anymore. Okay, so I'm going to take my square root. I'm going to multiply by the part that's causing the issue, which is the square root. Multiply straight across. Can I multiply 6 times 61? No, because one is a square root and one is not. The square root of 61 times the square root of 61 is just going to be 61. Can I cancel out 6 and 61? I don't think 6 doesn't go into 61, and I don't think anything 3 or 2 does. Now I'm done. I can have a root on top. A square root on top's okay. On bottom, nope, can't do it. Okay. All right. So let's look at number 7 now. Number 7. There's a triangle that if you find cosecant of angle A, that's going to be the square root of 57 divided by 7. Using that triangle, now find the value, find the ratio, find the fraction for tangent of A for that same triangle. So the first thing I'm going to do is draw and label a triangle, right triangle. A and B are interchangeable. So if you have A on top and B on bottom, that's okay. C is going to be the right triangle, the right angle. So the angle they're talking about is A. We know that cosecant. So let me look here. Cosecant. Cosecant is hypotenuse over opposite. Hypotenuse over opposite. So that means square root of 57 is the hypotenuse. Over opposite, right? So what side is, so opposite of A is going to be over here, right? B to C. I have to use that now to find the tangent of A. Tangent is opposite, so 7 is opposite of A, over adjacent. That's the missing side here. I don't know what that is. So whatever this is going to go right there. So I have to find that first. Okay. Here we go. So the missing side here is a leg. So it's going to be 7 squared plus leg squared equals the square root of 57 squared. $49 plus leg squared equals 57. Subtract 49 from both sides. I get positive 8. Take the square root of 8. Square root of 8 is not going to be a nice, pretty number. Square root 8. Look for pairs. Okay. So let's look for pairs in 8. 8's got a pair of 2s. So that means I can take out 1 2, and that leaves a 2 on the inside. So that means this side over here is 2 times the square root of 2, which means this side goes over here.
If I had my triangle like flipped the other way and then A was on top, would they be switched?
So you should get the same fraction. So if A was up here, so let's say I had A up here and B down here, then your focus is over here, right? So 7 would be here, and the square root of 2 would be here. Yeah. So yeah, if you switch A and B, you should still get the same answer as everyone else, because then opposite's a different spot. Okay, almost done. Not quite done because now I have a root on the bottom. So one more step. What is causing me to do this? Which part of the fraction is causing me to not be done? Just the square root, right? Is the regular 2 on the bottom causing an issue? No, if that 2 is on the bottom, that's not causing an issue. So you're going to multiply by the thing that's causing the issue, which is just the square root of 2. That's the only thing that's causing the issue. The regular 2 on the outside is not causing an issue. It's just the square root. Okay, so I multiply straight across, and I get 7 times the square root of 2, right? Because I can't multiply 7 and 2 to make 14. Now, the bottom, I have a 2 out in front, and I have a square root of 4 when I multiply, right? What is the square root of 4? 2, right? So really on bottom, it's 2 times 2. Then you're finally done. 4 is okay on the bottom. And 7 and 4 can't be reduced. 7 and 4 cannot be reduced, so we're done. Okay. Okay, so the last 2 I want you to try on your own. Last 2 I want you to do on your 8 and 9 I want you to do. Those are the extra problems I would have given you, but I put them on here. So I want you to do 8 and 9. 8 and 9, I'll give you about 10 minutes to do 8 and 9, and then we'll talk about it. Okay? Okay. So I got the number 8, number 9. So it doesn't matter where you put A and B. It's always going to be, they're relative to each other. So like if I built a triangle and I switched A and B, that's okay. Secant is hypotenuse over adjacent. So if A was over here, this 2 would move over here. Okay? It's always relative. So don't worry about, a lot of times when you're doing this, you're like, oh, where's AB? Where's B go? Where's A go? It doesn't matter. Okay? It doesn't matter. As long as you put it in the correct location, you'll always get the same answer as everyone who has a different triangle than you. Okay? Because triangles can look different. Triangles can look, they're always going to have a right triangle. Right triangles always have a right angle, but they can be flipped around and stuff like that. Okay? All right. Okay, so tape in your notes, and then we'll do some more practice on Monday.